Alright, so I'm going to work through the rest of those problems that you saw in our class notebook that we didn't have the chance to get to in class. Alright, so problem 2 from your textbook says to consider height CH in right triangle ABC with right angle C. So, first thing I'm going to do is I'm going to draw a right triangle, right angle C, and we have A and B. And I want to consider height CH. So there's H, and a height is always going to be perpendicular here, okay? Alright, so we are trying to prove that AC squared is equal to AB times AH, and that CH squared is equal to AH times BH. Now, there's a couple of theorems from elementary geometry that we could apply here if we know them, and that is, so I'll state these. So, but we're not going to use them because I'm not going to assume that anybody remembers these or saw these in their old geometry class. But instead, I'll show you kind of where these theorems came from, because that's basically what this problem is asking us to do. So the two theorems are that a leg of a right triangle is the geometric mean between the hypotenuse and its projection onto the hypotenuse. And so in this particular problem, the leg we're referring to would be AC, the hypotenuse would be AB, and the projection of AC onto AB is AH. And so that gives us, when you're setting up a proportion, the geometric mean is always going to go here and here, right? So those are the means in a proportion, and the extremes in this case are the hypotenuse and its projection onto the hypotenuse. And so you can see how cross multiplication gives us that AC squared is equal to AB times AH, okay? Similarly, we know that the altitude drawn from the right angle to the hypotenuse of a right triangle is the geometric mean between the two parts of the hypotenuse that it divides the hypotenuse into. And so here, our altitude is CH, and those two pieces that it divides the hypotenuse into are AH and AB. And so CH, the hypotenuse, is the geometric mean, and the extremes in this proportion are AH and HB, And again, cross multiplication shows us that CH squared is equal to AH times HB. All right, so these two theorems are really sort of shortcut theorems, but what they do is give us a shortcut where we're really just applying this concept of similar triangles. So when we draw an altitude from the right angle of a right triangle to the hypotenuse, we're really creating these two smaller right triangles that are both similar to the larger right triangle. So in this picture, triangle ABC is similar to two other triangles. So we have triangle ACH and triangle BCH. And remember, we always want to list the vertices of our triangles in corresponding order. So if I'm looking at this triangle ACH, well, obviously angle A is equal to itself, so I'm going to list that in the same location as angle A in the original big triangle. H is my new right angle, and so I want to list that in the same place as my original right angle C. And then this angle at this vertex corresponds to the angle B. Oops, I don't know why I wrote B there, C. So triangle ABC is similar to triangle ACH, and it's also similar to this new little triangle over here. So again, in my original triangle, angle B is going to be in the same place. H corresponds to the right angle, and this angle corresponds to angle A. And so I want to call that triangle CBH. And so now we can set up ratios of corresponding sides. So for example, the AC squared equals AB times AH. AC is your hypotenuse, right? So the hypotenuse of triangle ACH, right? And so the hypotenuse of triangle ACH corresponds to the hypotenuse of the original triangle AB. So I can think about it that way. So original hypotenuse AB and hypotenuse of the medium triangle here, AC. And so that ratio is going to be the same as both the short side of the original triangle to the short side of the medium triangle, ACH, and also the same as the medium side or the longer leg of each of those triangles. So here we want to deal with, it looks like AH and AC. AH we can see is the longer leg in this medium triangle. AC is the longer leg in our original triangle. So longer leg in original triangle over longer leg in this new triangle. And again, I can cross multiply, excuse me. So again, I can cross multiply and get the desired result. Similarly, CH is the shorter side in my medium triangle, and it's the so it's the shorter leg, and it's the longer leg in my smallest triangle here. And so in this case, we're looking at hypotenuse, and AC and AH are longer leg. So those are the ratios that we set up here. And then if I'm trying to work with CH, AH, and BH, what I'll set up, let's see, So CH is the shorter leg of the medium triangle, and BH is the shorter leg of the smallest triangle. So these are my short leg. And so then what else? So then I want to set up medium leg. So CH is also the medium or the longer leg, the medium length side of my smallest triangle. And my longer leg of my medium triangle is AH. So I can say that CH over BH is equal to AH over CH. And so in this ratio here, I'm saying the ratio of shorter legs is equal to the ratio of longer legs. And so in this purple one, I was just looking at my original triangle. And maybe I'll write it this way. So here I was looking at triangle ABC over values in triangle ACH. And here I'm looking at CH and AH, so I'm looking at triangle ACH over BH, and CH is triangle CBH. So original triangle to medium triangle, and medium triangle to smallest triangle.